Assalamualaikum warahmatullahi wabarakatuh. Hi guys, my name is Amirul Afif bin Khalid. I'm from BETT section 1 stroke 2. This is the second video that I have uploaded in YouTube. Before this, I upload about band pass filter. But today, I would like to tell you about my assignment mini project, which subject is control principles. The topic is about cruise control system. So before I go further on my presentation, I would like to introduce my member teammate. Of course, I'm not doing this alone. I'm doing this with my 5 members. So before I start, I would like to introduce about our member. The first one is me, Amirul Afif bin Khalid. My matrika number B0716103229. So the second member is Muhammad Hafiq bin Harmizi, matrika number B0716103229. Our third member is Fitrah Nur Hidayah binti A. Basha, which is metric number is B0716102120. Our fourth member is Ahmad Shafiq Ezri bin Zaidin, metric number B0716102290. And our last member, Khairul Anwar bin Sawal, which is his metrica number is B0716103322. So that's all my teammate, my member that have been together finish it our mini project assignment. So let's go about our topic, which is cruise control system. So this cruise control system that have been read in article, they have two article that have related in cruise control system. First is modeling and controller designed for cruise control system, but the second one is PID control designed for cruise system by using a genetic algorithm. So for more further, I would like to pass it to Fitrah Nur Hidayah to explain it more about cruise control system. Check it out, yo.
Assalamualaikum and hi, my name is Fitra Nuhidayah. I'm going to tell you about cruise control system. A system that automatically controls the speed of the motor vehicle, takes over the control of the car to maintain a steady speed as set by the driver is servo mechanism. Control and maintains the speed of the car through journey while speed is controlled by the controller in order to provide the desired speed at which the car is to be maintained. Basic model of cruise control provides the driver a push button for setting a speed reference. In picture below has 5 buttons, which is on, off, set or accel, resume and course. It also has a seats control the brake pedal. Importance of cruise control: heighten the comfort level and easiness to driver when driving a car without have to control the pedal frequently. Less tiring and by pressing buttons instead of pedals to controlling the speed of car. Second, some drivers use it to avoid subconsciously violating speed limits. Third, improve the dynamic performance of the automobile and reduce pollution due to exhaust. Block diagram of cruise control. This block diagram is the closed loop control system. For the input is the desired speed of car. For the controller is the set on or off button. For the actuator is the acceleration. For the plant is the car or vehicle. For the sensor is the speed sensor and the output is the actual speed of car.
Assalamualaikum. My name is Muhammad Afiq. I'm going to talk about the 10 article that we do the research. For the first article, the article is about the cooperative adaptive cruise control for string stable mixed traffic, benchmark and human-centered design. The author use the cooperative adaptive cruise control where it's the upgrade version of the adaptive cruise control concept. For its advantage, it improves the traffic flow dynamic by damping disturbance. Other than that, it helps to increase the highway capacity through shorter gap. For the informations, the meaning is the shorter gap is that the gap between the vehicles can be shortened, and because of that, the capacity of vehicles in highway can be increased and the traffic flow can be smooth as possible. But the length of the cooperative adaptive cruise control string is expected to arise from need to provide sufficient lane changing gaps in multi-lane highway environments. Other is clustering vehicles within the cooperative adaptive cruise control string, consideration regarding light and heavy vehicle string position and maximum string length. For the article 2, is about the intelligent cruise control theory and experiment. For this article, the author used an automatic vehicle cruise control (AVCS). For it, it utilized parking space efficiently, where the vehicle park automatically. Other than that, it reduced the space between car on the highway. It helps the vehicles to automatic parking and control the speed between the car on the highway. But for the disadvantage, cost is going to be a major factor with high price equipment use. But the most critical disadvantage is that the technology used today is still not capable of full automated vehicle control system. For article number 3, is about autonomous intelligent cruise control. The author used autonomous intelligent cruise control where it effect on the traffic flow and compare its performance with that of the human driver models. So the driver can sit back and relax and enjoy the ride. For its advantage, it better and faster in transient response that leads to a smooth ride and traffic flow. Other than that, the potential flow increased when a proportion of vehicles on the highway are equipped with it. For its disadvantage, there are limitations of the theoretical model, so they use a simulator to get the detailed information on the vehicles. Other than that, the autonomous intelligent cruise control does not comparative with other vehicles that have the same control. Also, the autonomous intelligent cruise control can lead to potentially large gain in capacity only if certain highly unrealistic assumptions hold. Article number 4 is about application of microprocessor to cruise control systems. The author used a microprocessor for the control system. As for the advantage, microprocessor has power to compute virtually any complex control law. Other than that, it has ability to generate complex motion with precision accuracy. But for the disadvantage, it might get overheated and the limitation it imposes on the size of data. The microprocessor have limitation on the size of the data that can be input inside it. And for the last article number 5 that I'm going to talk about is an object recognition algorithm for adaptive cruise control of vehicle using laser scanning sensor. The author used adaptive cruise control. So this sensor is also used in cooperative adaptive cruise control (CACC) in article 1. For this adaptive cruise control, the advantage, it has the sensor that can measure speed of an object continuously so that it can detect the speed of vehicle surrounding. Other than that, it also able to ignore the info of other vehicle on another lane, follow the vehicle on the same lane. It means that it from the when this sensor detect the speed of in front vehicles and the back vehicles, so it can control the speeds of the driver of the vehicles that the driver drove.
Hi guys, back to host Amirul Afif. So the next article is Article 6. So based on the article development of intelligent cruise control system, the author used intelligent control system for cruise vehicle. So that's mean the advantage of this controller is that it able to optimize the traffic flow and also utilize the road capacity efficiently. But it is just an idea to reduce the fuel cost of air pollution. So next article. Based on the article, Stop and Go Controller for Adaptive Cruise Control. The author used Stop and Go Controller. It means the advantage is that drivers are able to relax while the vehicle move at high and low speed according to road situation. But the controller are still not be full utilized to change the speed of vehicle automatically. Next article, Article 8. Based on the article, Safety Issues in Intelligent Cruise Control. The author used autonomous intelligent cruise control. As for the advantages, it can override and take over the system when it meets its requirement to help assist the vehicle to stop. It able to switch to control system based on the situation. But when it switch, a sudden jerk on the vehicle occurs because of the longitudinal dynamic. Okay, for the next Article 9. Agent-based modeling of eco-cooperative adaptive cruise control system is the vicinity of intersections. The author used a control system. The author used a system called Cooperative Adaptive Cruise Control (CACC). As for the advantage, implement a fuel optimum vehicle trajectory by discretizing the solution space and finding the minimum path optimum solution. But it affect minor street traffic where vehicles have to wait longer than usual at red traffic light. So the last article, Article 10. Based on the articles, experiments towards a human-like adaptive cruise control. The author used an adaptive cruise control system where it able to understand driver driving style and vehicle application control (VAC). It has different speed control logic, which is artificial neural neural network (ANN), calibration of linear function, and lastly, not less, based on calibration on polynomial function. Other than that, highly responsive traffic system that adjusts itself to avoid accident can be developed, but the cheap version of it still not yet realized. So that's all 10 articles that have been presented by Hafiq and also me. For the next question will be introduced by Khairul Anwar bin Sawar. So, thank you.
Assalamualaikum. My name is Khairul Anwar bin Sawar, and I'm going to explain a little bit about the open loop configuration and the closed loop configuration of cruise control. This is the closed loop configuration, open loop, sorry. This is the open loop configuration. This is the configuration where we put in the Simulink, where it consists of step block, transfer function block, and the scope for the output graph. In the transfer function, we put the transfer function as follow. The numerator is 1 and the denominator is s square plus 10s plus 20. This is the coding part we put in the MATLAB to get a better graph result, where later I will show you. This is the output of the graph, the characteristic of the output graph from the open loop configuration. The rest time is about 0.884 second, and the settling time is about 1.59 second. The peak time is 2 second, and the steady state is around 0.95 in value, or in other words, around 95%. This is the graph we get from the MATLAB, shown here. the rise time of the graph, 0.884 second. This is the settling time. The settling time is about 1.59 second, and the peak for this graph is about 0.05, where the steady state error is about 95%, and this 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 peak value achieved at 3 seconds. Here, as we can see. Next, this is the graph from the Simulink. Shows the same result, but in different time range. This is the closed loop configuration. This is the configuration we put in the Simulink. It's almost the same as the open loop configuration. It also got the transfer function block, the scoop block, and the step block, but we add some more block, such as the sum junction and the PID controller. Therefore, we built this as the closed loop configuration. The PID controllers consist of the peripheral, the integrator, the differentiator, and N is for the attenuator. Here we tune the PID controller as follow in this value. Then we manage to get the rise time, the settling time, and the other characteristic like this, where this figure shows what happened inside the PID controller, where the increasing value of Kp, Ki, and Kd will affect the rise time, the overshoot, and the settling time, and also the steady state error of the graph result. Here, as we can see, the rise time for the closed loop configuration is about 0.316 second, a little bit smaller than the open loop configuration. The settling time is also changed to 1.1 second from 1.59 second in the open loop configuration. For the overshoot, we managed to get 9.42%, where from our findings we learned that the overshoot should be below 10%, then the configuration is okay to be used. And the peak time for the graph to reach steady state is about 1.09 second. A big difference in the open loop, where the open loop is 3 seconds. This is the closed loop configuration graph. Here we get the settling time, 1.1 second. Around here we managed to get the settling time 1.1 second. Sorry, before that, the yellow line shows the steady, when will the graph should be at steady state. The purple pinkish graph is the graph from the closed loop configuration input. This shows the rise time for the circuit is the 0.3 second, something around here. It's the rise time. The settling time is about 1.1 second here, and that's all. This is the closed loop configuration. That is all for me. My name is Karel bin Sawar. Next slide will be presented by Ahmad Shafiq Azri. Thank
Hello,
you.
my name is Ahmad Shafiq Azri bin Zaidin. I'm gonna talk about comparison of open loop and closed loop. First, I'm gonna talk about an open loop system. Open loop system that I understand is control system act completely on the basis of input and the output has no effect on the controller action. While the closed loop control system consider the current output and alters it to the desired condition. Next is before I start a comparison between closed loop and open loop. As we can see, this is the open loop system graph. The rise time is 0.884 second. The settling time is 1.559 second. The final value is 0.05 second. What I understand that the final value that not reach 1 is not stable graph. Next is the closed loop graph. Closed loop graph, what we can see is the rise time is 0.316 second. The settling time is 1.1 second. The peak time is 1.9 second. And the final value is 1, which is the stable graph. Next is I'm gonna talk about the comparison between the rise time between the closed loop and open loop. First, the rise time of the open loop is bigger, which is 0.884 second. So the proportional and the integral decreasing the value of rise time that we get in open loop, and the derivative added the small change in rise time that y on the closed loop we get the rise time smaller depend on the open loop. Before we get through this, I'm gonna talk about PID. P is stand for proportional. I integral, and D is derivative. P is the pass of the P is past. I is integral is present. D is future. What we can understand from this is past P is past from graph that we get. I is present of graph that we get, which is after we tune through PID. Then D is future of the graph. Future of the graph means after we tune it and we get the stabilized graph. Next is the settling time of the open loop system is 1.59 second, which is also bigger than closed loop system. The reason is because the proportional added the small change on it, then integral increase it after the derivatives, decreasing it back to get 1.1 second settling time in closed loop system. Then the peak time for the open loop system is a little bit slow, which is 3 seconds, depend on the closed loop is 1.9 seconds. This is because the PID detected the problem, then PID tuned it back, which is the proportional and the integral decreasing it, and the derivative added small change on it. Because of that, we can see on the previous graph of the open loop and closed loop system, the rise time changed from 3 seconds to 1.9 seconds. After that, the percentage overshoot of the open loop system is 0%, and the closed loop is 9.42%. The proportional and the integral increase the value, and the derivative decrease it back to obtain the overshoot of 9.42%. Last is the steady state error for the open loop is 0.05 volt, and the closed loop is 1 volt. And for our understanding is one word is steady state error on the graph, then it's open loop system. We get the steady state error is 0.05, which is have steady state error. PID once again add to obtain the no steady state error proportional, and the integral decreasing the value, and the derivative make no change on it. Through this, we understand that PID have designed a closed loop system with fast rise time and no steady state error. PID help to tune unstable wave to be a stable wave. Thank you.
Okay guys, we are already at the end of our presentation. So, I will summarize about the cruise control system is cruise control system represented as present, future and past control system. We learned that cruise control system had been used in our commonly day life for quite a while now. As for an example, we can see intelligent cruise control system had been implanted in some trailers in West Country, which is the system are used to control and limit the speed of the trailers based on the desired speed limit the driver sets. Other than that, stop and go cruise control system, which is Tesla company had implanted in their car for detecting obstacle, auto parking and many more. So usually for the system are working in a heavy traffic where the car will detect an obstacle in close range and stop the car. When the obstacle are moved, the car will automatically move itself with a safe speed until the process are repeated again. So guys, you understand that? So we need to end our presentation, our video. So if you like this video, please click on the button like on the YouTube channel. So thank you for listening.